Hello, my kiddos. Today we are going to be talking about balanced and unbalanced forces. So, here is our title. Forces, balanced and unbalanced forces. And unbalanced forces, which is TEK 8.6a. So make sure you label your paper. TEK 8.6a. So before I got on the camera, what I did was got a ruler and I just made my template for my Cornell notes. So we did this before, but if you're new to this, what you do is just get a regular old something to make a straight line with. And I just drew a straight line a little bit past the red margin. That's probably like maybe 2 inches at the most. And I did that on front and back. And we're going to be in our ISN, of course. But I did this on the front page. And I also did it on the back page. So make sure you use a ruler and copy the same template as well. So starting off, we're talking about balanced and unbalanced forces, okay? So starting off, the first thing we need to know is, what is a force? What is a force? So if you know from Cornell notes, you know the questions always go on your left side and the answers goes on the right. So what is a force? A force is a push or pull that causes an object, and we are going to be underlining certain words, object's motion, underline motion, to change. And when I say change, I mean a force can cause it to start, an object to start moving. It can cause an object to stop moving. It can cause it to slow down. And if it causes it to slow down, then of course it can speed up. Or simply change direction. And make sure you write in all of these little notes. It is going to be quite tedious, but I promise you it's going to be beneficial for us in the end, okay? So there's our force. The second one we're going to be discussing. What is acceleration? What is acceleration? And that's your question. So, of course, that goes on the left-hand side. Acceleration, my kiddos. Acceleration is the measurement of change in an object's velocity. Underline change and underline velocity. Basically, to summarize it, is basically how fast an object is moving. How fast, an object is moving. Okay? Before we get to balance and unbalanced forces, we talked about force, we talked about acceleration. Now we have to discuss what is friction. So all of these terms, I'm pretty sure you have heard of it. You are familiar with them. We're just writing it down for clarity and just, we want to be a little bit rusty about these certain topics. So friction. Friction is a force that works against, underline against. It works against motion. So it's like the enemy, right? Well, not really, because sometimes friction hurts. Helps. Friction is a force that works against motion as surfaces rub each other. It's the little thing that causes us to slow down, right? Okay, and then finally, we're almost getting to balanced and unbalanced forces. One more thing. It says, what is the unit of measurement for force? You may already know, but just to make sure we are all on the same page, force, my kiddos, is measured in newtons. Underline newtons. And just in case, we're going to use the abbreviation capital N. Now, what are balance forces? Number 5. What are balanced? So I had to make sure you guys understood the prior knowledge. Now we're getting to the T. What are balanced forces? Capital sentence. Balanced. First means to stay constant. Now, if we're staying constant, we are basically staying the same. So balance, stay constant, or stay the same. Now let me give you a little visual real quick, and do not judge my picture. So balance, it means to stay constant or stay the same. So for example, let's say I have a bike. Here's my simple drawing of a bike. Do not judge me. Here is my bike. It is staying still. There is no force acting on it. Therefore, it is balanced. Now, let's say I have another bike. Now, this bike, it is moving, but guess what? It is going the same speed in a straight line. So therefore, this bike is also balanced. Make sure you're copying these notes. So therefore, balanced forces, underline, are forces that does not, underline, does not cause a change, and you guessed it, a change in motion. What I did was I flipped my paper over. I'm now on the back side. We are now on number 6. We're going to be discussing, we talked about balanced forces, so of course this one has no choice but to be unbalanced. So your question is, what are unbalanced forces. What are unbalanced forces? Unbalanced forces are forces that always, so the opposite of balanced forces. These forces always, underline always, cause a change in motion. Underline, causes a change in motion. So back to my cute little bicycles. So let's say I have another bike. Here are my wheels. Here's my handlebar. Here's my seat. So let's say this bicycle's in motion, right? Let's say a force causes it to speed up. That would be an example of an unbalanced force. Or you can say an unbalanced force causes it to slow down. That is also unbalanced. Unbalanced forces. So, examples include speeding up. We're just going to write speed up for short. Slow down. Or simply, even if it changes direction, that's an example as well. So a force can cause it to change a whole new direction. And if it changes direction, it can definitely change its position. Okay, and the last one before we go to part 2 of our notes. Number 7, what is a net force? So this week we're going to be talking about net forces and unbalanced forces all week long. So please make sure you're copying and listening to these notes. So what is a net force? Net force is the sum, and you know what that word means. The sum, when I say sum, I mean the total of all forces. We're going to be either adding or subtracting. So you add or subtract the force. And we're going to do some examples of it, of course. You add or subtract the force. What I want you to underline, I want you to underline sum and total. And I want you to either underline add. I want you to underline add or subtract. Now, keep in note, net force. You're going to have questions that ask you. So very important, net force. Whenever the net force is equal to 0, meaning there is no force acting on it, remember that it will always be balanced. Anything greater than 0, you're going to be unbalanced. We're going to do some example problems. But anytime you see a net force, you calculate it, and the net force is 0, the net force will be considered balanced. Okay, so now after you're done watching video 1, I want you to close out and open up video 2 and continue copying down the notes. See you later.